Get started. So this time we get started here. We want to talk about the equilibrium of a consumer. So how does the consumer maximize utility and what's the condition? So let us say we have two games. One is called, well, Angry Bird. And the other one we call Candy Crush. So when we use this example, it's a little bit different from what you perceive. As a matter of fact, can anyone tell me, hold on. Okay, John Bo, do you have to pay to play Candy Crush and Angry Bird? Do you have to pay?
No, just pay.
You just download it, right?
Yeah.
So this is a little bit different from the reality, okay? The reality is that you don't have to pay for these two. And so the opportunity cost to you is actually your time. So your time to play, whether it's Candy Crush or Angry Bird, is the same. So later on we will talk about this. It is called perfect substitute, okay? You have your time to play this. But let us assume you have to pay a price for these two, okay? So it's different from the reality. Okay, so then, we have two persons. Okay, so person A and person B. Okay? So now the question to you is, who likes Angry Bird better? Okay? Who prefers Angry Bird? 谢信佑. Who likes Angry Bird better? A. Okay? So, how to tell? So let us say, okay, each of them, A and B, right? If they want to get one more unit, okay, one more unit of Angry Bird. So for person B, if he wants to get one more unit of Angry Bird, this is the amount of Candy Crush he has to sacrifice, okay? But then for person A, okay, for person A, if he want to get one more unit of Angry Bird, he has to sacrifice this much of Candy Crush. So who loves Angry Bird more? Person A, because he's willing to pay a higher price, okay? Questions? So here we have two persons. Okay, two different indifference curve. So this is indifference curve for B. This is indifference curve for A. Okay, but we want to talk about a case here. So two indifference curve cannot cross. Here, be careful, we are talking about two different persons, okay? This person A is different from person B. But now we are going to talk about, for one person, if he has two indifference curves, they cannot cross. Okay, why? Again, so we have, anyway, let's forget about Angry Bird and Candy Crush. We just have X and have Y. Okay, we talk about the same person. Okay, so this is IC1 indifference curve 1, and here's IC2 indifference curve 2. So this is two indifference curves for the same person. And so let's assume this is point A, here is point B, here is point C. What I'm going to show you is that two indifference curves cannot cross. Okay, so why? So this is indifference curve 1, right? Okay? So according to this indifference curve, Zheng Yiling, so according to this indifference curve, right? What is the relationship between the utility of A and utility of C? What's the relationship between utility level at A and utility level at C? What's the relationship here? Yes, exactly. So UA is equal to UC. So utility at A is equal to utility at C. Because what? Because they are all at indifference curve 1, right? Okay. 우동현. So what's the relationship between A and B? Excuse me? Okay. So utility A is also equal to utility B because they are both at IC2. Okay, so what's the conclusion? The conclusion will be UA is equal to UB and is equal to UC, right? Okay. So there is not quite right? Because you say indifference curve 1 is not indifference curve 2. But it turns out that if they cross, right, at point A, what happens? It has to be the same indifference curve. Okay? So because of this indifference curve, okay, two indifference curve cannot cross. Questions? So when you draw a picture of indifference curve, you cannot draw it randomly. They cannot cross. If they cross, there's something wrong. Okay, now we go back to how to get the equilibrium. Okay? So here we have, sorry again, Angry Bird. And here you have Candy Crush. Okay, Zhang Chewei, do you still play Angry Bird? If someone of you still play Angry Bird, you must be very angry, right? Anyway, okay. So last time we draw a picture and I say, well, I cannot find a good example for that. And today I try to use Angry Bird and Candy Crush. And then we just elaborate, how to make adjustment there. So, suppose we have this and we have this. So this is indifference curve 2, indifference curve 1. And here we have point A, point B, point C. So remember that there is a slope for this, right? And we say the slope for the budget line represents the relative price of X and Y. And so here we have Angry Bird and Candy Crush. But let me also use X and Y. So suppose this is X and here is Y. So the slope of the budget line is Px over Py, right? And this represents, the relative price of X and Y. This is the price in the market, okay? And this is the price in your mind. For indifference curve, it represents your satisfaction, your utility. And so what's that? That's Mux over Muy. So how much you love it, Muy can tell. Mux can tell. And as we just showed you, right? When the indifference curve is very steep, it means you love X, so Angry Bird. If the indifference curve is flat, you love Candy Crush, okay? So this is the tangent. Anyway, Zheng Hongxi, can you tell me what's tangent? Tangent. So this line, tangent to indifference curve at point B. So what's tangent? Two words. 庄博超. Tangent. This line cuts, it touches, okay? It touches indifference curve at this point. So what's this line we call? Right, exactly. But if we talk about line, so what's that? Cut. Yes, exactly. Okay? So you can tell, this is the budget line, right? It's flatter. and this one is steeper. Okay, so what does that mean? That means, sorry, anyway, I can do this. So at point B, what does that mean? That means MUX over MUY is greater than PX over PY. Okay, so Huang Xiuhui, at this point, what should you do? So here, right? Okay, this is the budget line. Okay, and that's the price there in the market. And this is the indifference curve. The tangent, the slope, means how satisfied you are with X and Y. And this one is steeper, right? And this one is flatter. So this is the relationship there. So the slope of the indifference curve is higher than the slope of the budget line. So what should you do? So, Huang Xiuhui, X and Y, which do you like in this case? I shouldn't have erased the Candy Crush and what's that, Angry Bird, 2% comparing that. So,
Because
excuse me?
Angry Bird.
Exactly, right? But can you tell me how to pronounce this? Just pronounce it. Read it. X, not X.
Okay.
You got it? Okay, good. So, when you get example, this is much easier, right? So because the slope is steep, it means X, Angry Bird, okay? Angry Bird gives you more utility. So what should you do? You should buy more X, or in this case, Angry Bird, okay? Right? So what should you do? You should move down here, right? Okay? Okay, good. So we are going to do the other case here at point C. So the point C is flat, right? It's flat. So not here. So at point C, what should you do? What's the relation here at point C? In point C is that this one, the slope of the indifference curve is flatter, right? Flatter. So MUX over MUY is less than PX over PY. Okay, so Hong Daixuan, what should you do? Excuse me? So you're gonna buy less of X and more of Y. Okay, so how are you gonna move? You're gonna move up here. And so this point is what we call interior solution. Okay, if you read a book, it's called interior solution. And at this point, what happened? MUX over MUY is equal to PX over PY. And we're gonna arrange it a little bit. So you have MUX over PX, MUY over PY is equal to MU dollar sign. Okay, what does this mean? It means each dollar you spend buying X or buying Y, the marginal utility is the same. So you have to spend to the point that every dollar you get the same marginal utility. Right? And of course you have many goods, right? You have many goods, so they will be the same thing. Okay, so this is the equilibrium there. And there will be some question on this in your test. Okay, midterm just like 3-4 weeks away. Questions? So this is by algebra. Okay, this is by algebra. Can we do that with, sorry, this is geometry. Okay, this is geometry. Can we do that with algebra? Yes, we can do that. Sorry, algebra. And so we're gonna have utility function. Okay, so what will people do? You're going to maximize your utility, okay, utility x and y, okay. Generally, if we want to maximize a utility function, it's quite easy, okay. So suppose this is a function, okay. If you want to maximize it, we need to check the changes. But I know that some of you have not taken calculus, but you just listen to me. We won't have this kind of question in the test, but I need to let some people know how to do that, okay? So in this case, we talk about changes, okay? So rate of change. In this case, we want to know. We have to use calculus, okay? We want to know how the slope changes, okay? So this is the function, and if we want to know the slope, we need to use differentiation. So in this case, the slope, just like this one, tangent, right? So you know that when it is at the top, okay, the tangent should be flat, and the slope should be equal to 0, okay, the same thing. But you will find there are two possibilities, because it can be here or it can be here. So then we have to check again. So if you find out the slope of this function, and you want to know that whether it's a maximum or it's a minimum, then you have to check another rate of changes. So this one is what we call first order condition. Okay, first order condition. And if you find the first order condition, you cannot be sure whether that's maximum or minimum. You have to check again. How does the function change? So if it is going down, okay, if it is going down, what does that mean? You know that this will be, so you are going down here, right? So it's at the top. If you are going up here, right, it means it's at the bottom. So this is called second order condition. Second order condition. So first order condition, f prime is equal to 0, and f double prime will be less than 0, okay? So we say differentiation is to measure the changes of the function. So first order condition, we make sure that at this point it doesn't change, okay? So it's at the top or at the bottom. But then after you find out this first order condition, you need to check the second order condition. So whether this slope is going down or going up, okay? So f double prime has to be less than 0. So in this case, then you can make sure that it is a maximum rather than a minimum, okay? Okay. When we get back here, unfortunately, it's not that simple. Why? Because for a consumer to maximize utility, it is subject to your budget constraint. So subject to, or ST means subject to, your budget constraint. So you have Px times x plus Py times y is equal to m. That's your income, okay? But suppose you have learned calculus, it is not that difficult. So there's a person, a mathematician called Lagrange. Lagrange invented a Lagrange function. So we have Lagrange is equal to u x y plus, lambda m minus px times x minus py times y, okay? So because we have a function and also budget constraint, right? So we don't have any way to deal with it. But Lagrange invented Lagrange multiplier, okay, and Lagrange function. So we can actually turn this whole thing, a utility with budget constraint, into a function again, okay? So then we can do this. So partial x partial x, partial Lagrange. So why we use partial? Because we have two variables, x and y. So we use partial, okay? So then you have partial u, partial x, plus. Okay, if you differentiate, right? Let me see. Okay, 陈子帅. So utility function, and to differentiate with respect to x, so it is here. What about here? M differentiate with respect to x, what you get? Lin Yu Yang. Okay, M differentiate with respect to x, what do you get? M is a constant, right? So what do you get? 陈千云. Right, exactly. So this part is gone, right? This part is also gone because there's no x. So here you have minus px equals 0. So this is the first order condition. And so we also have partial lambda, partial y equal to partial u, partial y minus py equals 0. So then, oh, sorry, there's one thing missing because lambda is here, right? Sorry, lambda. So lambda px equals 0, lambda py equals 0, okay? So partial u, partial x, this is called MUX. So MUX is equal to lambda times px. And here you have MUY equals lambda plus, times py, okay? So then you have these two. So lambda is equal to MUX over px is equal to MUY over PY is equal to MU dollar sign. So either way, we use geometry and here calculus, we show the same thing. That in the equilibrium, okay, so MUX over MUY is equal to Px over Py. And so this is exactly the slope of the Bachelor line, and this is the slope of the indifference curve. So we have two ways to show that. This is the way to get equilibrium for a consumer. Okay, any questions? No questions? Okay, so we're going to elaborate a little more on two concepts. And then after that, we will review the book and do the homework together. Okay? Question, Cho Guangming, questions? No. Okay. Have you learned Lagrange? Cho Guangming, have you learned Lagrange in calculus class? No. No? Really? Okay, in the textbook, they have a function, it's called Cobb-Douglas, okay, Cobb-Douglas function. So they may have something like this. So, okay, anyway. So uxy is equal to x to c's power and y to d's power. And then you can get the main function for x, the main function for y, and then, so you can check the book, there's something here. But for those who haven't learned calculus, don't worry about it. In our test, there won't be something like this. Okay, now we get to income effect and substitution effect. Okay, so we have income effect and also substitution effect. So when we want to measure, remember we talked about this, right? So when we want to find out what changes in the market, usually we have to assume something does not change. So that's called other things being equal. As you know, today we have increase in price of oil, right? Price of oil goes up. So what does that mean? That means you have to substitute oil for something else. For example, ride a bike rather than your motorbike, or take a bus. But if you continue to use your motorbike or a car, what happens? You become poorer. So your income actually is the same, but because the price goes up, you feel poorer. Because what? Because to pay the same amount of oil or gasoline, you have much less left in your pocket. Okay, so here, if you want to measure income effect, the price has to be the same. Okay, you want to measure income effect, price has to be the same. The same thing, you want to measure substitution effect, income has to be the same. And how are we going to deal with it? Okay, let's look at here. So we have X and Y, okay? So let us say, let's assume we have some price decrease, okay? That's easier to elaborate. And then you can do the opposite for your homework. Okay, so let us say, originally, this is your budget line, and now price decrease. Okay, so let us say, because you know the new year is coming soon, for U.S. Thanksgiving shopping season is coming soon, so people have sale, right? So cut a price to entice you to shop. So price goes down, so PX goes down. Okay, any questions? So the original budget line is here because PX goes down, so it becomes flatter, right? Okay, so we have two solutions. The first solution is 0.1 here, okay? And the second one is 0.2 here, okay? So indifference curve 1, indifference curve 2. Questions? Okay, so from 0.1 to 0.2 actually has two parts. The first part is income effect, because the goods is cheaper, right? So you can, if you buy the same, you still have more money left. Okay, so more, it sounds like you get more income. So this is income effect. And substitution effect is that because it's cheaper, so you buy more of X. Okay? So how to deal with it? So for income, okay, we want to say income, sorry, the same income. When we talk about income, there are two concepts. The first one is called Slutsky. The second one is called Hicks. What's the difference? When we talk about Hicks, he said, if you can have the same satisfaction level, okay, if your satisfaction is the same, or your indifference curve is the same, it means you have the same income. Okay, that's one thing. And Slutsky said, if you can purchase your original bundle, that would be the same income. Okay? So, if we want to find some point that is at the same income level with 0.1, we have two choices. The first choice is Slutsky. I can draw a budget line across 0.1. So what does that mean? At this budget line, I can also purchase one, right? So that means I can purchase the original bundle. So this line and this line will be at the same income level. Okay, it makes sense because I can purchase this. And here I can purchase this. So supposedly, I can afford to buy one. Okay? Here or here. So that would be the same income level. That's one. But usually we stick to Hicks' idea. The idea is that at the same indifference curve, at the same satisfaction level. Okay, so then